Hi, everyone. My name is Dr. Kim Tait. I'm the Tech Endowed Chair of Mineralogy at the Royal Ontario Museum. I'm just delighted that you could join us today for the Curator Conversation, the digital program that explores themes and subjects from ROM collections alongside industry professionals. I would like to take this opportunity to thank TD for their ongoing support of this program. I'd like to begin by acknowledging that the ROM sits on what has been the ancestral lands of the Wendat, the Haudenosaunee Confederacy, and the Anishinaabe Nation, including the Mississaugas of the Credit First Nation, since time memorial to today. Today's Curator Conversation celebrates Mars Sample Return Mission and the unique opportunity it gives us to learn more about the past, present, and the future of life in our solar system. I would like to welcome Dr. Tim Haltigin to today's program. Tim is a planetary senior mission scientist at the Canadian Space Agency. In this role, he has helped lead Canada's efforts in finding new ways to explore planetary bodies throughout the solar system. He received his PhD from McGill University, where his research revealed similarities in the evolution of ice-rich terrains on Earth and Mars. In 2016, he was in the running to become Canada's next astronaut. And in 2017, he had an asteroid named after him, 130066 Tim Haltigin. Tim currently serves as the Canadian Mission Manager for OSIRIS-REx, a mission that will return a sample from asteroid Bennu to Earth in 2023. As much as I love talking about OSIRIS-REx, that is not what we're going to do today. We are going to talk about Mars. So Tim, I really welcome you to this program, and thanks for being here.
Thanks so much for having me. No, I'm looking forward to it.
All right, so first of all, we're going to pull up an image, and I want you to tell us a little bit about what you see here. And I'd like to say that it's one of the cooler images of Mars, but I'll let you weigh in on that.
Absolutely. So this is an illustration of some of the engineering magic that happened on February the 18th, a couple of weeks ago. So this was after a 9-month cruise, something called the Sky Crane, setting down the Perseverance rover on the surface of Mars. And to me, this is really, honestly, one of the most incredible moments in space exploration history. Because what we're seeing here is a representation of the last portion of what was called the 7 minutes of terror. And so you have to understand, after this spacecraft, after having flown, nearly 500 million kilometers over the course of about 9 months, had to go from 20,000 kilometers an hour down to 2 kilometers an hour in the space of only 7 minutes. And so the way that it worked is that the spacecraft that entered the atmosphere used the atmosphere itself to slow down a little bit, deployed a parachute that slowed it down even further. The back shell of that spacecraft then broke off, and the Sky Crane actually flew out by itself with the rover still attached to its belly. It had used the cameras on board almost like eyes, and so it was comparing what it was seeing versus the maps that had been uploaded to its memory ahead of time to get a sense of where it was and to try to fly in the right direction. And eventually got down to when it was about 20 meters above the surface, just sort of hovered and slowly lowered the Perseverance rover down on a tether, put it softly down on its wheels. The tether then broke off, and the Sky Crane flew away. And there we were with this wonderful SUV-sized robot safely on the surface of Mars. So it was just incredible.
What's really amazing about that, for me at least, is that this has to do it all by itself. I mean, the communication time between Mars and Earth is, what, 10.5 minutes?
At that point.
Yeah, so I mean, this is all happening. This is all sort of predetermined kind of information that had to be all queued up for all of these fantastic engineering feats to drop it down perfectly. Not even a bumper or scratch, which is amazing. So, where did it land? Did it just land somewhere randomly? Where would it have landed?
No, so there was an awful lot of effort actually that went in internationally to picking where specifically on Mars that we wanted to go and conduct this mission. And so what's really neat, the goals of this mission are, first of all, to sort of understand what the environment was like on Mars, several billion years ago, and potentially look for signs of life if it had ever arisen on Mars. And so what we needed to do was to pick a site that not only had features representative of what we thought were previous climates and previous environments, but also a setting that was really conducive to preserving signs of life if there are any. And so what's really neat here, the Perseverance rover set down in a place called Jezero Crater. And Jezero Crater is a location on Mars that we have overwhelming evidence used to have a giant standing body of water in it. So here's sort of a perspective view. And if you'll notice, sort of coming down from the top left of the screen down is what looks like a channel out into this sort of fan-shaped deposit of sediments. And so what's really neat here is that this is evidence that there used to be an ancient river that was flowing at this location, carrying sediments along with it, and emptying into a large, sort of a large lake. And what's neat is that these sediments then built up into what's called a delta, which, you can see in New Orleans, for example, where the Mississippi empties in, or the Fraser River where it empties out in Vancouver. And so this delta had built up with all of these sediments and over time solidified into rock. And so there's a number of cool reasons, or a number of cool things about this. First of all, by sampling these rocks, ultimately, it's almost like going back in time by 4 billion years, because rocks are incredible storytellers. They really preserve signs of the environment in which they were formed. And so by studying these rocks, we can get a sense of, what was the climate like, maybe even what was the water like. And deltas, we know on Earth, are wonderful places to look for sort of signs of microscopic life, because they would get carried along with these sediments and slowly buried. And so potentially by drilling into these rocks and sampling them, what we're doing is we're getting environmental history from Mars, but also a wonderful location to look for signs of life.
Absolutely. Now, there's the next image that we're going to pull up here. I just wanted you to look at and maybe comment on what kind of emotion this
Sure.
brings to you, because we did watch this together
Yes.
live, and there was some big feelings for me, at least. I don't know about you, but maybe you wanted to talk about that a little bit.
No, absolutely. It was honestly, it was overwhelming, because in the moment itself was one thing, because I had it up on the big screen, so there's just the personal excitement of is it going to be successful? But I was also sitting on the couch with my wife and my daughters at the time, and so we were all watching together, so it was a family moment. But at the same time, I had a headset on with you and with colleagues from NASA and the Jet Propulsion Lab, and some of our colleagues from Europe that are working on this, all experiencing it together. And so, at the moment when it touched down successfully, that we had confirmation, there was a celebration on the screen, there was a celebration on my couch, there was a celebration in the headset. And it was just an incredible moment that, so many hundreds of people have worked on this project for, close to 8 years now. And so this really was an individual moment that, signifies hundreds of thousands of hours of effort by a team across the world. So it's just incredible.
So I could see on the front desk there that there's some peanuts. And can you explain to the crowd what that signifies? Do you remember that?
Honest, I can't. Can you?
No, yeah, there was the whole peanut story. So this was news to me. So I didn't recognize or realize this, but I guess it's sort of a tradition in landing rovers, etc., that you have peanuts on hand and start chewing on peanuts. It was a sort of everything went great one time when somebody was eating peanuts, so they have to keep bringing out the peanuts. So I don't know if you noticed, the Michael Meyer from headquarters on our call was chomping down on peanuts as well. So I guess I'm informing you and everybody else that there is a peanut thing. So next time there is a rover landing, you must bring peanuts.
Oh, that's amazing. Listen, and whatever works, if that helps,
yeah, exactly.
Set it down safely.
Totally.
For sure.
So now the Mars 20 was phenomenal. Everything went amazing. But what's really exciting about this, at least for me, and I think you might share this as well, is this is sort of the first step in a series of steps that is going to be leading to samples coming back to Earth. Can you talk a little bit about that?
Sure. So Mars sample return in general has been really one of the almost the holy grails of planetary science for coming on 30 years now. And it's only now that we're technologically capable of doing it. And it just so happened that the planets lined up perfectly this decade in order to be able to pull it off. And so the Perseverance rover really is the first step in this interplanetary relay to bring these samples back from Mars. And so what's going to happen is this mission is going to be the one that scientists are going to use to drive around and investigate, where do we want to collect samples from. And you can see on the image in front of you, on the end of the arm, there's a turret, and on that turret is a drill. And so this is the one that's actually going to be physically drilling out the samples that we want. So they're sort of, the size of, your pinky finger or a stick of chalk, really. And they'll put these samples in a tube and seal them and leave them in a place that we can go collect them later. Now, what's going to happen later in the decade is we have to put down another small rover called the Sample Fetch Rover. That is this small, nimble vehicle that's going to drive around and pick up the samples that Perseverance collected, drive back to the lander, put them in a small rocket, and that rocket is going to launch it into Mars orbit. But that rocket isn't powerful enough to get these samples all the way back to Earth. And so it's going to take a third spacecraft to come and capture that sample canister in orbit, turn around, and then bring it back to Earth. And so by the time all of this happens, it's now the year 2031. So we have an awful lot of work ahead of us for sure. But the advantage of sample return is really it's just incredible. The way that I like to think about it is sample return missions are almost they're the gift that keeps on giving, right? If you think about rocks that were brought back from the moon 50 years ago, people are still making brand new discoveries on those today because we have equipment that just flat out didn't exist 50 years ago. And as a science community, we have questions that we didn't know how to ask before. And so really what we're doing is bringing back, and we're turning essentially every laboratory on Earth into our spacecraft. And it's just incredible because the instruments that we can fly with Perseverance itself are obviously incredible, but they're limited, right? I mean, they have to be really ruggedized and very light, whereas we can bring them back and study them with room-sized equipment here on Earth. And so the power of the discoveries that we'll be able to make is just incredible. And those discoveries will continue for decades to come.
That sounds like a lot of work. Now, would this just be NASA that is going to be doing this, or is there going to be more people involved?
Oh, no, certainly not. So this is a worldwide effort. This is an international endeavor to try to bring this back. And so it really, you can think of it as almost the whole planetary science community coming together and trying to do it. So NASA and the European Space Agency are doing a lot of the heavy lifting in terms of the hardware that is actually flying in space. But in terms of the planning and the execution, these are teams around the world. I mean, you're involved in the MSR science planning and understanding how the samples will be curated when they're back on Earth. I'm involved in developing the overall science program for how we're going to study them and who gets to study them and how we're going to distribute them around the world. And what we're trying to do is to make sure that the absolutely the best science takes place on these samples. And so we're going to be involving scientists from around the world, including Canada, ensuring Canadian scientists can help make these amazing discoveries.
Oh, that's really great. I'm glad that everybody is involved in this and that it's such a worldwide effort. We're getting to meet some really exciting and interesting people from all over the world. So I've really enjoyed this process so far. Now, why are we studying these rocks? Like, what are we ultimately trying to figure out by studying Mars? And we have our own planet. Why do we need to go somewhere else?
Sure. Well, there's a number of reasons. I mean, when you think about planetary science in general, it really comes down to two fundamental sets of questions. The first one is, how do planets form and evolve? So what's the life cycle of a planet? And one of the best ways actually about learning about the Earth is to compare it to its neighbors. Why are we the way we are? Whereas, right next door, there's a planet that took a very different path. And so understanding the environmental history of Mars can help tell us a little bit more about how planets evolve and form in general, which in essence allows us to learn more about how the Earth forms and evolves. A lot of other things. So on Earth, rocks are constantly recycled. So new rocks are formed, but old rocks are destroyed, and so there's this whole rock cycle on Earth. And so the result of that is what happens is that the really, really old rocks disappear. We just have no geological record of sort of the first, 500 million years of Earth's history. Whereas on Mars, that's not the case. The rocks that formed there stayed there. And so especially at this particular location, we're going to a place that's actually older than any known place on Earth. And so what we're doing is we're filling in that data gap in terms of solar system history of how planets formed during that sort of first 500 million years of the solar system. So that's sort of the environmental and the science piece. But what we're also doing here is honestly addressing one of the most fundamental questions that we face, which is, are we alone in the universe? And so we know that the conditions on Mars were conducive to life development. I mean, the water was, there was liquid water, there was a thicker atmosphere. And so the conditions we know through previous missions were right for life. So the question becomes, was there life? And can we find evidence of it? And to me, if we can do that, I mean, you think about the types of questions that would open up afterwards. So if you do find signs of life, well, is it the same as life on Earth? And if so, why? But then is it different than on Earth? And if so, why? Was there, did life arise independently elsewhere in the solar system? And so to me, it's, the science of the planetary history is one thing, but here we are, potentially discovering signs of life elsewhere in the solar system. So to me, it's just fascinating.
Well, yes, that is pretty cool. So, I guess you kind of already answered my question, but what is the most exciting part of this for you personally? As you are a geomorphologist, there's some research background that you have here, but you are working at the Canadian Space Agency, sort of in a the management role here. But I'd be curious, what makes you want to get up in the morning and work on Mars?
Well, it's an awful lot of things. So it's one of them is just the scientist in me, just the pure curiosity of trying to figure these things out is one thing that I'm excited about. One of the things is that Mars sample return has been called almost impossible. And I think it's that word almost that keeps a lot of us going as well. It's that challenge of, can we actually do the unthinkable? But to be perfectly honest, the thing that excites me the most is thinking about the kids and the students that will be involved in this. I mean, when you get to be part of a flight mission, there's a few years of really intense work and really intense excitement. But then often you're on to the next thing. Whereas in this case, by bringing the samples back, again, I'm thinking about people that are, I spoke to a grade 5 class the other day. And when I was thinking about it, it's like, okay, so these grade 5 students are the ones that are going to be in university when the samples come back in 2031. And these are the people that are going to be joining that science team and making some of those initial discoveries. So you think about someone in grade 5 right now really is the star candidate for potentially finding life on another planet. And when you think about it that way, I'm so excited because I love science more than probably most people, and to think that here we are, basically creating generations of science to be done, especially in Canada. It's to me such an honor to be part of that.
It's a good thing we're so young, you and I. We're not getting older, right? So we will be around for a long
time to
study these rocks. So that's really exciting.
No,
now I've been watching. What's that, sorry?
No, I was just gonna say, it's our job to go get them for sure. It's our job to go get those samples and to bring them back and to protect them. But it's very much these students' job, to be ready to work on them. And so we're We are young and we are going to be around forever, clearly, but having some backup just in case will be good.
That might be a good idea. That's very wise of us to do that. So yeah, I'm speaking to grade 4 to grade 6 classes on Monday. So I'm really excited
Nice.
about that. And you have the kind of the same reaction I do, is thinking about that from a long-term perspective. If we could talk to students of that age right now and get
Sure.
them really excited about this mission, maybe they will be the ones that will actually make those measurements in the future. So that is really exciting to think about.
But what
The,
about you? Can I just ask, like, as a scientist, because I mean, you study Mars minerals, and you know, you've been able to rewrite the history of Mars and change, you know, change civilization's understanding. Like, what are you looking forward to as a scientist for this?
What gets me excited, we do have Martian meteorites in the collection, which is super exciting, and that's what I, spent a lot of my research time on. But yeah, no, these are going to be really special rocks that are coming from, as you mentioned, the ancient lake that might have hosted life, and that really gets me excited. It's not that we're expecting to find life per se, but we can find in the rock record sort of that information about, was there life? What did life look like? And how did it react with the planet? I'm really excited about that. And I really look forward to those samples coming back in the future. That's, cracking those tubes for the first time would be really exciting. So I've been watching, there's some really fantastic questions that have come through, Tim. So I want to maybe address a couple of those now. So what happened to the crane after dropping the rover? That is a really great question. Do you want to address that?
Yeah, for sure. So the sky crane, after it had lowered the rover down, the tethers were cut, and really it just flew away. So it had sort of what's called a divert maneuver, and it used its engines to fly away by a few hundred meters, just to make sure that there was no danger of it coming down on the rover itself. So it landed not as softly, a few hundred meters away from where the rover currently is.
How or who funds work on Mars?
Sure.
Great question.
So it depends on the project. The rover itself, the vehicle, and many of the instruments on board were funded by NASA. So this is a NASA-led mission, this particular one. There are contributions from other countries on board. So some of the environmental instruments are from Spain, for example. There's a radar that's going to be sending radar waves into the ground to map what's under the ground, that came from Norway. And so there were international partners that contributed pieces of hardware to this. On the Canadian side, we are supporting a number of scientists on board. And so there's a gentleman named Chris Hurd from the University of Alberta, Marieke Schmidt from Brock University, and Richard Leveillé from McGill University that the Canadian Space Agency is funding in order to support their work as part of the science team. So really, it's a joint effort.
No, that's great. I am so glad somebody asked about this. Somebody is asking about the drone helicopter. And, do you want to talk a little bit about that? We did talk about the sky crane. I was able to slip that in, but really the star of the show is the drone.
Yeah, so there, so alongside, actually right now attached to the belly on the underside of the Perseverance rover is a helicopter that is called Ingenuity. And so this is a technology demonstration. This will be the first powered flight on another planet. And the plan basically is to let release the helicopter from the bottom of the rover. The rover will drive away to a safe location. And you'll power up the Ingenuity helicopter that will then fly around, take some images, and come back. So it's going to do this multiple times. And really what this is sort of a future-looking technology in terms of future robotic missions and potentially even future human missions. To have a drone alongside can go and scout different locations very, very quickly and come back and bring back images and bring back data. So really, this is a test to see, is it feasible that we can fly one of these things around? But it sounds easy enough because we fly drones on Earth all the time, but on Mars, it's a much different story. The atmosphere on Mars is only about 1% as thick as the atmosphere on Earth. So it's super, super thin. And what that means is that there's not a lot of air molecules to actually use to generate lift to fly. So the way to think about this is like, imagine if I put you in a swimming pool, but the water was only 1% as thick as regular water, and I asked you to start swimming. It would be really hard because there's just not enough, there's not enough material to create that buoyancy. And similarly here, there's just the air is not thick enough, the atmosphere is not thick enough for the rotors to catch on. So the design that went into this is just incredible, super lightweight materials, and when it works will be really, really spectacular.
So another question, there's so many good questions here. We could be talking for hours, but we're going to try to just pick a couple here. So have we received any pictures or samples yet? If so, how long does it take for pictures?
Yes, we have. I mean, I think image-wise, we're up over 1,000 already. And they're pumping them out, a lot of them, to the NASA Mars 2020 website almost immediately. And so the very, very first image came within 5 minutes of the landing. There's a little camera that's just above one of the wheels. And that was the first image that was taken just to demonstrate that the vehicle was upright, to get a first view of the surroundings and things like that. But since then, they've taken images with all of the cameras on board. So there's ones that help with sort of looking for hazards near the wheels. There's other ones that are used for navigation, but then up on the mast, you can see on the left side of the screen here, the cameras sort of act as the eyes of the rover. And so it's been looking around, it's been driving, in fact, as well. And so, yeah, no, if you go to the NASA website for Mars 2020, just look it up. They're releasing images publicly all the time.
All the time, and they are so cool.
Oh, they're incredible. It's incredible.
For this, to try to pick a couple images to pick, and I could have gone nuts. There was so
for sure.
And what's great is that it's free to use. So all those images, if you wanted to present them to your friends or family or
publicly wide open.
Yeah, exactly.
I think the second part of that question was, are there samples already? I think, right? So the answer to that is no. To get the rover up and moving fully is actually a really long process. It's going to take probably a couple of months before they really get into the full science activity. So right now, the team is very focused on just making sure all the systems work. So doing short drives, using all the instruments on board, turning them on, turning them off, exercising the arm and the turret. And so really just, sort of that, it's like after a long road trip, you get out of the car and the first thing you do is sort of stretch and make sure your arm's still good. And that's exactly what the robot is doing here. So I think in earnest, the science mission is probably going to start up in a couple of months.
Yeah, no, for sure. So another question here is it safe to bring back objects from Mars? We certainly don't need any new viruses and so on. Are these objects sterile? So maybe I'll take that one because I've been thinking about this quite a lot. As part of, I've been working on the curation portion of this. So thinking about the samples coming back to Earth in nominally 2031. And this is something we think about quite a lot, because we want to not only protect the samples from Earth, we have to protect Earth from the samples. So what we're going to do is when these materials come back, they're going to go to a laboratory with the highest rating biohazard safety protocols on Earth. So these samples will be contained in a facility where they can be safely looked at and studied. And what we're going to do is either sterilize them so that they can be released, or they're not coming out of there until they're safe. We want to make sure that everybody is safe, and also that these samples are safe. We want to make sure that we are preserving these samples for a long time. And if we do find some signals of life, we want to make sure that it's from Mars, not from Earth. So there's going to be a lot of containment protocols in place. We've been thinking about this for years already, and we meet weekly to talk about this, and all of the plans are in progress, but it's going to take us like over a decade to come up with exactly how we're going to handle these samples, how we're going to maximize the science out of them. And not only just for us, because we're going to live forever, but for, you know, the grade 5 students in the future, and for the students that haven't even been born yet. You know, I think about the Apollo samples. I'm able to apply for them and
Right.
test them in my laboratory. I wasn't alive, you know, I wasn't born yet when those samples were drilled and brought back, or captured and brought back. So that's really exciting, is that this is not just our lifetime, but it's, you know, as you said, decades and decades in the future of scientists that can be working on that. So that is super exciting. One of the questions here is, I've read that this is the first rover that has been able to capture and transmit back us sounds from the surface of Mars, which is very exciting.
Yep.
What can we do with that information to better understand the current environment on Mars?
Sure. So this is also another technology demonstration. You're right. This is the first time that a microphone has been deployed on the surface, which is really neat. So that really gives you a sense. We've got some sensors in terms of, you know, wind speeds and wind directions, but really what this does is adds a bit of richness to that data, you know, so you can tell do some basic atmospheric science and understanding the dynamics. So how, you know, how air is moving along the surface as well through just the analysis of the sound of it, which is really neat.
I just heard like this week, like first videos of the lasers being shot, you know, so we hear these sounds as scientists in the lab, but to hear it on another planet is something completely different. So that is super exciting. Another question here, I know you're both working on this, where will the samples be curated once returned? That is a great question, great question. We know, since the samples are going to land in the United States, that they're going to land at the Utah Test and Training Range. So it is likely that there's going to be the first containment facility will be in the United States, but kind of, you know, where in the United States, we don't know yet. And, you know, what happens after that is still a lot of discussions that are going to need to be made between both, you know, United States, European communities as well. And that is TBD at this point. So it's a really exciting discussion, talking about, you know, where these samples will go, how we're going to store them, you know, what temperatures we're going to store them, what kind of gases we're going to use, what kind of, all of these details. You know, there's more details than I ever thought. You know, I just, I had no idea, you know, and the more I get into this, the more exciting it is to think about these things. So I like this question. This is going to be our last question, because I know you're a busy person, but are there plans in the works for landing on another planet? If so, which one and when?
Oh boy. So right now, let's think. There's obviously a lot of activity that's going to be going to the moon shortly. There's actually a really cool mission that's coming up called Dragonfly, that's going to put down on one of the moons of Saturn called Titan, which is going to be really neat. So that one, I believe, is launching in 2026. And yeah, so that is the next plan there. So it's landing on Titan is the next step, which is going to be pretty amazing.
There's a lot of exciting things on the horizon for planetary science.
For sure.
So if there are people listening that are younger, there was a couple questions from 7-year-olds, etc. I really welcome them to get involved and to look at the NASA website as a great resource. You know, there's also, I'm sure, some information on the Canadian Space Agency's website as well for you know, upcoming missions and all of the exciting results that are coming back. You know, I'm sure there's going to be other programs like this, because there's one question: are there more sessions on this to come back to? I'm sure there will be. We have a great programs department that are trying to come up with some great ideas of topics. So if you have some other ideas of things you want to talk about, we can talk more about space in the future if you suggest that, but that's going to have to come from the crowd. But you know, at the ROM, we have so many different topics that we can talk about. So that's really exciting. And Peggy and Bob thank us for the great presentation. So
thanks,
Peggy and Bob, for being here. That's really great. So
thanks so much.
I just want to thank you so much, Tim, for being here, and you know, just really great conversation we've had today about Mars. I can't wait to talk to you again about future missions, and as this mission progresses as well, some of the exciting results that come back. and in the future, talking about samples coming back from Mars. So I look forward to that quite a lot.
Anytime. Thanks so much. This was a lot of fun, and we have a lot of work ahead of us and lots of fun ahead of us too. So let's come back to it again.
All right. Thanks, Tim.
Thanks.